All right, we're going to get some notes down to review some things you may or may not have noticed and make sure we have some notes before going forward. So this is on the back of 3.6 practice, and it's called review, but actually some things will be new. Okay, before analyzing a rational function, we should always factor first with an exclamation point. Always factor first. And then these factors are going to give you clues. Okay, so when we factor, watch, if a factor cancels, that's where the hole is located. So if a factor cancels, then that's where the hole is. Now, sorry, the bell just rang. The factor that doesn't cancel in the numerator, the x value gives you the 0, and the factor that doesn't cancel in the denominator will give you the x value of the vertical asymptote. Okay, so let's review. Zeros. What do the zeros look like on the graph? Anytime you see the word 0, those are the x-intercepts. X-intercepts. And how do you find analytically? So this was on some notes. You set the non-canceling. I don't know how else to say that. Oh shoot, spelling. Does canceling have one L or two L's? I get mixed up on double letters. Set non-canceling factor in where? Where did the zeros come from? They come from the numerator. In the numerator, numerator equal to 0, and then solve for x. Okay? All right, what's the y-intercept look like on the graph? It's where the function or curver, oh dear, Mrs. Keener, what am I doing? Where the curve, C-U-R-V-E, crosses the y-axis, but where is the y-axis? The y-axis is the one going up and down, right? Curve. You guys know what a y-intercept is, yes? How do you find analytically? You always plug in 0 for x. Let x equals 0. And the lights go off. All right, here we go. A removable discontinuity. A removable discontinuity is called a hole, you guys. Do you see how a hole is when something has been removed? So the point was removed. Removable discontinuity. How do you find it analytically? Okay, ready for this? The factor that cancels. Set the canceled factor, F-A-C-T-O-R, equal to 0 and solve for x. Solve for x. So when your factor cancels, you set that equal to 0 and solve for x, and that's your hole. Actually, that's the x value of the hole. To find the y value, you plug the x value in to find the y value. Okay, vertical asymptote. Vertical asymptote, what does it look like on the graph? On the graph, it will look like a vertical dashed line, but it is where the function is undefined. Undefined. The function is also undefined at the hole, but the vertical asymptote, it's where the function is undefined as well. Okay, because anytime this hole and this vertical asymptote would make the denominator 0. So if the factor cancels, it's a hole, but that value would make the denominator 0. And then if the factor doesn't cancel, you would still have a value in the denominator that would make it the whole thing 0. I don't think I said that right. Denominator equal to 0 makes the whole thing undefined. So how do you find the vertical asymptote? So this would be set non-canceling factor. I'm still going to look up if canceling has one L or two L's. Set non-canceling factor, but not in the numerator. That's where you get the 0. This is going to be in denominator. In denominator equal to 0 and solve. End behavior. End behavior. What does that look like on the graph of a rational function? That's going to be our, for now, our horizontal asymptote. Horizontal asymptote. So the vertical asymptote is where the function is undefined, but the horizontal asymptote is really the end behavior, what is happening on the left and on the right. So even though these two use the word asymptote, they mean different things, and we will explain in class why they both have the same word asymptote. How do you find it analytically? Well, we're working on this, okay? So for now, I think we saw on one example that if you have, I'll just do a couple examples, okay? If you have 3x squared over 4x squared, then the horizontal asymptote is at 3/4. Or if you have 2x squared over 1x squared, then the horizontal asymptote is at 2. Okay, but there's other scenarios that we're going to get into. So we haven't really talked about this yet. That's okay. Domain. The domain, what does it look like on the graph? It's all the x values except the discontinuities. So except the holes and asymptotes, discontinuities. And the range are all the y values except the y value of the discontinuity. So for the range, you have to look at the y value of the hole, and you have to skip over the horizontal asymptote. All y values except y value discontinuities and the horizontal asymptote. You got to skip over that. All y values except discontinuities. In the range here, that would be the hole you're jumping over and the vertical asymptote. Okay. How do you find that analytically? We're working on it. We're working on it. This is supposed to kind of be reviews, a place for you to go look for help. Okay, you ready? This is review. If this is your x value, what would your factor be? What would this come from? This would come from the factor x minus 2, right? Because it's what we're doing is we're setting these factors equal to 0. So if we set x minus 2 equal to 0, we would get x equals 2. Okay, so if this is a factor, like let's say this was the hole, this was the factor that canceled, then where would the hole be? The hole would be at x equals -4. See what we're practicing? If x equals -1/2, what would the factor be? So watch. How does this work? If x equals -1/2, here's what we're going to do. We're going to move this 2 in front. So we're going to have 2x equals -1, and then add the 1 to the other side. So then we have 2x plus 1 equals 0, which means what is the factor? The factor is 2x plus 1. Cool? Okay, so set this factor equal to 0. Now we're going the other way. Now we're solving for x. And what would we do? We would subtract 1. 3x equals -1. And so x equals -1/3, -1/3. All right, what do we do with 7/5? So if we're going to multiply by 5, so we have 5x equals 7, and then subtract the 7. So we have 5x minus 7 is the factor where this x value came from, if you set this factor equal to 0. Because that's what we're going to have to do. We're going to have to be setting all these factors equal to 0 to find the 3 things. We're going to be looking for the hole, we're going to be looking for the 0, we're going to be looking for the vertical asymptote. All right, last one. If this is the factor, if you set that equal to 0, what would the x value be of whatever that is? It could be the 0, the hole, or the vertical asymptote. -3 divided by 2. Yeah? Okay. After this, you're ready to go on to 3.7. All right. Good luck. Leave a comment on the Google Classroom if you have any questions. I was going to look to see if canceling has 2 L's. Did anyone look it up? it's on, it's not on these. Hold on. Oh, shoot. I don't have it. So I'm going to Google on a video how do, oops. I know Siri could do this. How do you spell canceling? That doesn't look right. The 2 L's just doesn't look right, does it? Cancel. I think it'd be really awesome if you were still watching here. Cancel versus cancel. Canceling or canceling? When is the L doubled? I'm confused. Many. This is funny, right? Are you still watching? That'd be cool. Oh. Some words are spelled different in different countries. So it looks like in US we have 1 L, but in Britain, it uses 2 L's. So I don't know what I put on the yellow notes. I'm going to leave it with 1 L for now. All right, thanks for watching. Kind of strange that you kept watching, but that's okay. Canceling 1 L for now.